think we're going to go. Is that a thumbs up to go? Thumbs up to go. So I'll go slowly because people are still coming in because it's after lunch. Hopefully this won't be so boring that it puts you to sleep after lunch. It's a bit of a tough slot to do. I'm Andrew Harmel-law. My pronouns are he, him. I'm a tech principal at Thoughtworks, which can mean that you're post-technical. And so what I'm going to talk about is the secret reason for me doing this talk is I actually got to write some code, which doesn't happen as much as I'd like. So many of the things that you see in this presentation, the dashboards, are Power BI script, which as far as I'm concerned is code because it's the only real code I get to write these days. The Power BI script that I and my client pair, Pete Hunter, so shout out to Pete who isn't here, but Pete was awesome. That's the secret reason of doing this talk, because we got to write some code, and we were both architects, and so we weren't allowed to go anywhere near production code anymore. But what I really want to talk about is the 4 key metrics unleashed. And I wanted to do the cheesy thing to maybe at least keep everyone awake for at least 3 minutes and ask to do a poll. So if you've heard of the 4 key metrics, stick your hand up. Oh, this is quite good, because there's a bit where I explain what the 4 key metrics are. Has anyone... That's people who've heard the 4 key metrics. Anyone used the 4 key metrics or been worked on a piece of work where the 4 key metrics are being used? Anybody? I'm glad Tristan put his hand up because I was on that project where we did it. Right, cool. A few. Has anyone actually used the 4 key metrics themselves to make their code and how they write code and the architecture, the practices, everything, used the 4 key metrics as a reason to argue with management as to why you should change things? 1 person, 2 people, this is good. That's what the talk is about. The talk is not about a secret thing to help your management, watch what you're doing. The 4 key metrics are for developers to learn where we're at, like someone else has said on a lightning talk yesterday. The metrics are for us as developers and people who write and deliver software. And if we learn to use them and understand them, then we can use them as a basis for an argument with senior management as to why we want to change the way we do things. That's what this talk is about. This talk is about how I've learned over doing this on quite a few clients, how I've set this tool up and set these metrics up, but in a way that devs, people like you and I, can use them to make our lives better. So, next slide. So for the benefits of people who haven't heard of the 4 key metrics, and just to kind of level everybody up, to explain what the 4 key metrics are, we need to go back 2 steps. So the 4 key metrics kind of got famous because of Accelerate, which is a book which is weirdly on Amazon listed as a management book. It's not a management book, but because of whatever, the insanity of the Amazon algorithm, it's listed under management books. It's not. It came from the DORA State of DevOps report. DORA State of DevOps report comes out of the DevOps movement. As a thought worker, I'm honor bound to remind you what DevOps is and what DevOps isn't, because people still get it wrong. So, as it says here, and this is why it's quite a wordy slide, because it's to remind me about things, the DevOps movement's been around for a long time now, but it's a cross-functional community of practice dedicated to the study of building, evolving, and operating rapidly changing, secure, resilient systems at scale. But the movement was all about the reason, it advocated for things like continuous delivery, continuous integration, breaking down silos between operations and developers, using shared tools, build and run. So we write our code, we run our code. All of these different things had moved to the cloud because it allowed lots of these things to happen. Lots of it was around about building up flow and getting into tight feedback loops. So as developers, we love feedback loops like pair programming and TDD and running our test in our build and stuff. DevOps just took that to natural conclusion and went, do you really know if it works unless you've got it in prod, right? So that was the DevOps movement. From 2018, Dr. Nicole Forsgren, ludicrously bright woman, plus a bunch of other people, famous people, Jez Humble, Gene Kim, started doing the DORA DevOps research program, because what they wanted to do was, specifically Dr. Forsgren, she wanted to prove that all of this stuff, which everyone kind of thought was a good idea, and it was based on loads of kind of philosophy of flow, which came from manufacturing, and lots of stuff which came from famous people like W. Edwards Deming and all of that kind of stuff back in the 1950s. They intuitively knew that all of these practices made companies better, made software quality better. but they wanted to prove it statistically. So they started doing this, 2018, they started running this questionnaire, and they would ask loads and loads of people across all different industries with all different tech backgrounds and all different tech estates and architecture and everything. They didn't care. But people who were building and running and delivering software, they asked those companies a load of questions. And then based on the responses to those questions, they then did some incredibly detailed, and this is a third of the book, statistical analysis, and they looked at the profitability and the non-commercial benefits of those organizations to find out if they could in any way be predicted by the DevOps practices that those teams were using. And they found that they could, and they found it at a stronger than correlative measure. So it wasn't just like the companies that do these things also, as a correlation, have good profitability and good employee satisfaction. There was a causative link. So it wasn't just because companies that do continuous delivery had people who are also good at writing code, right? There was a link between the act of doing things like continuous delivery, trunk-based development, lean product, all of these kind of things. There was a causative link between that and these things. And then when they had this information, the more of these things that companies were doing, the better they were at doing these practices, the better they were. They've also discovered that it was more likely to indicate how profitable they would be and how they would, how positive they would be rated on non-commercial things as well. And so they found that there was a 2x at least improvement. So the companies that were good at these things, the standard DevOps things, the stuff that Thoughtworkers bang on about all the time, that was a causative way of improving both commercial goals and non-commercial goals. So commercial goals, like companies who did these practices were 2 times more profitable, had 2 times greater market share and 2 times greater profitability. Maybe we don't care about that. I mean, I would argue that developers, we should care about what we build. But for us, even if you don't care about that, right, quality of goods and services, so the code bases, the qualities of the things we build were also better. Customer satisfaction was also better, so less bugs and less people complaining. But the fifth bullet point, and this is super important, employee satisfaction of working in these environments which had these practices going on, the more these practices were adopted and the more efficiently they were adopted, the better it was as a place to work. People would just say that it's a better culture, it's a better place to work. So that's why it's all good. So let's quickly jump to what they said. So if we work back from the right-hand side, the things that they looked at, the kind of indications of, if things were good, if organizational performance was good and non-commercial performance was good, they kind of stepped back and said, right, what are the indicators of those things? And these arrows, if we go back along the arrows, the things one step back on the arrows, these were the things that they found were stronger than correlatedly linked with these 2 things of organizational and non-commercial performance. So things like having a nice culture where people don't get blamed and like people, you celebrate failure and learn from mistakes, that was a strong indication of being good at these things. Job satisfaction was also a strong indication of things. So if people were happy in their job, then that was an indication that they'd probably be better code and the company would be making more money. Software delivery performance, and we'll go into that because that's part two of the 4 key metrics, was also strong. Sense of identity, which sounds a bit woolly, but like they found that people who could identify with the things that they were building and running, if that was high, then the other things, the commercial and non-commercial performance will be high. Plus some other things, right? There'd be less burnout, less deployment pain, and less rework. So how do you get those? We can step back even further. One way that drives loads of it is the DevOps practice of continuous delivery. How do you get better at continuous delivery? You do the standard things. Test automation, deployment automation, trunk-based development, shifting left on security, blah, blah, blah. That's the stuff they started looking at. As they ran the questionnaire year after year, they found there were other things which were also strongly linked to these goals on the right-hand side. So lean product development and lean management also had a big part to play. And then very recently, or like maybe a year or so ago, they also discovered that leadership could also have a really positive or negative impact. So therefore, transformational leadership which had vision, intellectual stimulation, all of these different things, right? They found that all of these things were, they could statistically prove would drive positive outcomes for organizational performance, like profitability, the bottom line, that stuff that the executive care about, but also non-commercial performance, including the stuff we care about. So that's why this is not a book. I mean, maybe it's a book for you writing a business case because you want to do some of these things here, right? You're like, just read the book. here's a quote from Accelerate, and it proves that this will, there's a very strong chance that this, if we do these things, it will improve things. But then the management might say, yes, but how do I know it's working? And that's where the 4 key metrics come in. So the 4 key metrics, and you might have heard about these actually, because they're not always called the 4 key metrics, they're called the DORA metrics or other things. But we throw them around a lot, but they're really smart. So they are deployment frequency, lead time for changes, change failure rate, and time to restore service. So these were the metrics which Dr. Forsgren and co. discovered that if you look at these and improve these across the board, so you can't improve, like I could improve deployment frequency if I didn't care about change failure rate. I could turn on, and like lead time for changes, I could turn my test off and check in lines of code. I can do a lot of deployments, right? But the quality of my code running in production would suck. Or I could focus tons on making it super secure, making sure that my systems always stay up by never letting any developer ever change anything ever again. That also sucks. So you've got to keep these two, the top pair and the bottom pair, balanced. But they found out that when you focus on these and watch them improving, then you would see improvement in all these things. And the way you improve them is by adopting all of those practices, the lean practices, the leadership practices, and the DevOps practices. These are so powerful and they work so well that Thoughtworks, with our tech radar, we've had the 4 key metrics in adopt since October 2021. Every project I've worked on, the last 3 projects with the last 3 clients that I've worked on, we've put it in the contract that we will come in, we will set up measurement of the 4 key metrics if the client doesn't already have it. We will set it up and we will be held to some aspect of performance against those things. Because we're so convinced that if we improve these things, then the quality of the software will improve, all of the other things which kind of flow from that. So that's awesome, right? It's really cool. It turns out, though, and even when you read the Accelerate book, which is a book, setting these things up is not as easy as it is. And that's what this talk is about. This talk is about, mostly it's about Pete and I setting this up for a client that some people in the audience worked at. Because we thought it would be easy, and it turns out that there's a bunch of stuff you need to figure out. So what I want to do is share how you can go away and set these things up. Because I want everyone to do this, right? You don't need to pay Thoughtworks to come in. I'll probably get shot for this. You don't need to pay Thoughtworks to come in and like do these things for you. There's a book. There's a whole book, and then there's this talk, and also this talk came from a chapter that is going to come out in an O'Reilly book, I think, in a month's time, and the chapter is just even more of my lessons learned. So there's 4 steps to the 4 key metrics. At this point, you will have calculated your 4 key metrics, and management can use them to beat you up. And then we go down here, and this is where own and improve. This is where you as developers and architects and people writing software, here, they're your metrics, right? And so, you don't really care if management's looking at them because you're using them to make your lives easier. So we're going to start off at the first step, which is define then locate. We're going to figure out which key things you need to find, where are you going to get the numbers from to do the calculations to calculate these 4 key metrics. Then we're going to talk about how you can turn that into a minimum viable 4 key metrics dashboard, aka a Excel spreadsheet, which is how I typically end up doing them. Then we'll talk about like when you can do the smart stuff. That's when Pete and I start writing code, all the goodness happens. And then we start using the dashboard and you get awesome conversations and really good stuff. So, step 1, define and locate. The key to defining and locating is, and this bit is not talked at all about in the book or in really, there seems to be a lack of blog posts or anything. Nobody really talks about this. There is an underlying mental model in Accelerate which comes from Deming and manufacturing and flow-based kind of ways of looking at the world, which they kind of just assume everyone gets. And it turns out, having worked with these in a lot of places, I thought I got, but I didn't. And I also assumed lots of clients just kind of understood it, but they don't. And it's the thing that underpins DevOps thinking. So typically, when someone has done some work, a story's come in, right? People, you've written the code and you've finished the code, it's passed all the local tests, et cetera, et cetera. You're ready to commit it and push it to a shared source control. So you're done. So you push you push and merge or whatever. Then something listening for those changes starts up. Like a pipe, we call it a pipeline these days, but it could be anything, all manner of things. It could be a human being still hand-rolling things manually. And then eventually, all of those tasks in that pipeline get done, and it gets deployed to production. So there's a few key things. Number one, deployed to production does not mean released for customers, because we're not beholding ourselves to product managers who want you to develop a product or a feature and then not turn it on for 6 months. We're thinking about when it's done, right? We think we finished so it's ready to go, so that all that's ready to make it available to customers is a flick of a switch. And like I say, the other key thing is at the start, you'll hear other people talking about other measures of things. There's lean metrics and stuff. This one starts when the development is done. So this should theoretically, like in naive imaginations, right? This is simple. I'm finished. There's some automated stuff's got to happen and it'll end up in prod, but it's not that simple. So this picture you never see. Unless you're running a gigantic mono repo and you build a gigantic monolith and deploy a monolith, your world will not look like this. So your world might look like this. If you're using Azure DevOps, which comes with beautiful, really easy, and I never thought I'd say this as a Sun employee, with a Microsoft product, but Azure DevOps comes with really nice, simple, easy ways so you can listen to your Git repository, you can build a nice end-to-end pipeline which can have as many stages as you want, and manual stages and all this kind of stuff. It can be configured as code, all of the things everyone tells you to do. It can be a completely independent pipeline, and it can deploy to, if it's Azure DevOps, to Azure or wherever you want to go, right? But you can do this with other things as well. If you're doing microservices, you might have something that looks like this. So you've got a bunch of independent things which have their own repository. When you make a change and you deploy it, something in a pipeline triggers and then picks up the pieces and then does the work it needs to do and deploys your microservice. This is one of the... You're not doing microservices if any collaboration has to happen between any of these pipelines, because one of the definitions of a microservice is it needs to be independently deployable. So if you're probably doing microservices, you'll have this. Again, you probably don't, right? Like, nobody lives in an ideal world. You've probably got this, right, because of history. You'll have like 3 or 4 Jenkins builds that kind of, number one starts listening to a GitHub repository, and then it triggers and it does a bunch of stuff, does some compilation, maybe does some testing, and then probably publishes an artifact to Artifactory and then stops. Then there'll be another pipeline, which I've stuck just here, but it then triggers based on a timer or something, maybe the fact the last one ended, but it triggers, gets the thing from Artifactory or wherever, Sonatype, other, Nexus or other binary Artifactory repositories are available, does some stuff, deploys it to an environment, finishes, blah, 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 stops. Maybe it pokes a QA who does some smoke testing or something, then it's finished. Then the next one fires up and starts up, and that's like the deploy job after someone's been to a change advisory board or something, or said, yes, we can deploy things. So it's a multi-stage process. DORA and the 4 key metrics, accelerate metrics, don't care about whether it's manual or not or whatever. They don't care about how many of these steps they are. They just care about the start, the fact there's a pipeline and an end. But the reason I'm talking about it is because you want to find your metrics in here, and this helps do that. You've probably not even got this. You've probably got that, right? But those are quite possibly not the same as each other. They're quite possibly in a wide variety of build engines because of fashions in technology which appeared. So you'll have like maybe some GitHub Actions doing some stuff, some old Jenkins stuff you can't turn off for some of the old stuff. You've maybe got some really old build stuff going on for some Microsoft C# or VB6 code that you wrote a long time ago or something, right? Loads of different bits. But basically, there's some stuff that listens to repositories, does a bunch of actions, and then gets you deployed at the end. If you've got this, you're still lucky. What I see most, and apologies, I couldn't figure out how to draw bendy pipes on Lucidchart. So this is my hand-drawn version of the diagram. You've probably got something like this. So Keith Morris, who's the thought worker who wrote Infrastructure as Code, the book, he calls this fan-in pipeline. And we see this all over the place, because it's where people have gone through the process of splitting everything up. They've had a monolith, they want to make it modular, so they've split up the code base into separate pieces, but they're still deploying a big blob of stuff at the end, or they just need to synchronize. They haven't, and it's hard, right? I'm not judging anyone. I may have written code which would do this in the past. You can't fully pry stuff together, right? So you've got your pipelines do some work, and then at some point you need to kind of bring stuff together, and something needs to wait for all of the right pieces to be in place, and then it can pick up and pull this change of this, and this version of this, and this version of this, and it puts it all together, does more work, a bunch more stuff, and then it puts it into production. This is fine. It's just, well, it's harder to grok, and it's also harder to get your metrics out of. The reason I'm showing you this is because if you have this, you have to do a bit more work up front to get your metrics. So what are the metrics? No matter what your picture looks like, you need to have, when a specific change is committed, to whatever you define as the shared kind of view of something. So maybe that's when a pull request is initiated, maybe it's when it's merged to master, maybe whatever, but you need to define it. You have a clock start, the timestamp when that change is shared and available to be pushed down or pulled down this pipe. Your next data point is the time when that change set was deployed. And deployed and like made available or something, right? So not as in like turned on from a product sense, but like if you deploy but then you do a smoke test, it's that point, right? It's after it's passed, it's like ready. If anything fails on this thing, you don't count it at all. You're only counting successful ones. I'll explain why later you don't want to count, well, I'll explain that now because I'll probably forget. You don't count failures, because if you count failures and you run your pipeline 100 times, but 98 of them fail, and they fail really fast, which is good, you'll end up with a really short lead time because, maybe it takes 3 hours to do a deploy, but your tests fail after 3 minutes. You'll get 98 3-minute build times and then 1 or 2 3-hour build times. That will skew your metrics. So you only care about, and it doesn't say this in the book, you only care about ones that work. So whatever you define as worked, available for a human being who isn't a developer to flip a switch and turn stuff on. So there's that. So this is where it gets hard, right? So if you've got deploy 264, which contains maybe 2 changes from repo A, 1 change from repo B, and maybe or maybe not a change from repo C, you need the lead, the start and stop time for every single change. The clock time for deploy 264 will contain within it the stop time for those 2 changes from repo A, the 1 change from repo B, and maybe the change from repo C. So you've got to unpack it. That's why it's hard. It's not impossible, it's just hard. So and I'll advocate in a minute for doing this manually. This is the bit where you'll hate yourself, and you'll want to write some code to make it better. So the next thing is change failures. So change failures, there's tons, and again, I thought there would be loads of people discussing this, but nobody does. The way the book describes it seems very, very specific. So it's like, one of the 2 metrics, the second pair of metrics talks about the number of changes which triggered a failure. It turns out even spotting failures is pretty hard, right? Sometimes stuff, you've got to have a pretty strict definition of what a change failure is, and I'll tell you what I think a good definition is in a minute. But then the effort required to go back and figure out whether or not that failure was triggered by 1 or more or none changes, because maybe AWS fell over. That's a service interruption, right? That's a service failure. It wasn't your fault. Maybe you could argue that at some point some change should have deployed your service to multiple regions in AWS, but you'd be stretching the point, right? So you wanted to find something and capture something which is your change failures. The easiest way I've seen it done is you do it as a ticket in Jira or Azure DevOps or something, and you rely on human beings, which is a bit messy and not brilliant, but at least then you've got something which you can continually improve, and you can continually improve quite easy. And what you want from those are, when there's a change failure, and the best way I've seen to define a change failure is when there's an interruption in service in your running systems, which stops people doing their jobs. And it doesn't mean that if it hasn't been discovered, but the QAs have discovered it, it doesn't count as a change failure. If someone knows, like it's been reported to you that it's barfed, and that might mean it's going slow, right? Might not mean it's broken. But if there are people who are dropping off your site, or people who can't do things, or are just less inclined to do things, that counts as a change failure. Log the change failure and then fix it. That's the clock start. The clock starts when you log the ticket. You could argue that maybe it took half an hour or a day or whatever, but you can know that and then work to improve it. The other thing is your clock stop. The clock stop is when service is restored. Maybe you restored the service by turning it off and turning it on again. So you haven't done any new changes, right? But it has been restored. That counts. Because all you care about is service stability. You don't care about how you fixed it. Hopefully you've put a ticket on your backlog to fix the root cause, the memory leak that was causing it to fall over. But you're not worried about that. That's the other 2 metrics. That's how fast can I deploy this change, right? How many deployments can I do and how quickly can that get out into prod? If I fix it by turning it off and turning it on again, double thumbs up. So those are our things. So that's what we're looking for. We're looking for information about commits, timestamps, which gives you a count, obviously. We're looking for number of deploys, and we're looking for failures, some measure of failures. You can get, so I've been in clients where we got smarter with failures. So there was a bunch of stuff in New Relic, for instance, and there was loads of alerts going off, so we started capturing things from there. Plus there was some other things, because they had some mobile apps, so we collated reports of failures from app stores and all these things, plus we did the manual thing. Other places just did manual or whatever. But what you want to do is kind of make sure that as far as you can, you've got a pretty good collection of the stuff, right? And you're as proud as you can be that the start time is as good as it's going to, close as it's going to be, and the end time is as close as it's going to be. That's what you want, right? And you just be honest with yourself. So that's part one. Part two is capture and calculate. So now you've got all your raw information. You now need to use those to calculate these 4 numbers, the 4 key metrics. So what are you going to do? What you're going to do is you're going to collect them manually by running JIRA queries, or by counting the number of Slack messages that appeared in the failure Slack channel, or by, like human beings are going to be heavily involved. So shout out here to Kylie, who is my current client, and she is still counting things manually. She's automated a bunch of stuff, but there's still a bunch of stuff that Kylie counts, because she's the improvement manager at my last client. And she does an awesome looking spreadsheet, and she does an amazing report. So yeah, capture this stuff. So let's talk about this, because again, this is not obvious. Nobody talks about how you do this, and this is non-trivial. So the definition and the location of your stuff is non-trivial. This next bit is non-trivial as well. So first up is deployment frequency. This is the easiest one to do, because it's just the count of the number of things that come out. If you've got fan in, you do need to know how many chain sets are in that deploy, right? Because if you've got one deploy, your deployment frequency is not 1. If that deploy has 5 chain sets in it, your deployment frequency is 5. Which sounds weird, but you've got to work back to your chain sets. So if you're aggregating stuff together, all your stats need to work together. There's a few of these little weird things which don't work. And basically they all drive you towards moving towards independent pipelines which work independently. It's not simply a count though, right? It's a frequency. So therefore, what you need to look for is to take the average per day over a period of time. Accelerate doesn't say what the period of time should be. Calculate daily figures. But the period of time is, Pete and I found was useful, and has now worked on more than one project that I've worked on, the last 31 days. So the average number of deployments per day over the last 31 days. Gotchas, which Peter and I may or may not have fallen foul of on more than one occasion, averaging an average. If you calculate the daily figures, it's nice to know the daily figures, but the daily figure will also be an average. Well, it is. Oh, no, yeah. If you take the average over a day and then the average over 31 days, you can't. It's statistically wrong. That's bad. Also, we were not counting days with 0 deploys. So we were like dumping a bunch of stuff into or doing some queries against Azure DevOps. So we would say, give us the total number of, give us the count, or not the count, give us all the deployments over the last 31 days, right? And then we would group them by day, and then we would do some kind of simple statistics to calculate, the average over that time and then the average per day. The problem was, if there was no deployments in a day, like on a Saturday, right? Hopefully people aren't working at the weekends. No deploys. We were getting like 26-day long months, which was like wrong, right? So we were like, why is this so weird? Because we weren't inserting blanks where a day had no deploys. So it will kick your arse, and you'll be like, why are arse? Because you've done, when you do this mentally, you do that right, because you divide by 31. But then we wrote the Power BI script, and it took us hours to figure this one out. Dates in Power BI are hard. So that's deployment frequency. So if you want to, and we'll talk a little bit about this in a few seconds, but if you want to slowly step towards your 4 key metrics, possibly the easiest one to start calculating and sharing is this one, deployment frequency. And it's good. It's not the only thing, and like I say, you need to balance them, but deployment frequency is nice. You want to deploy as frequently as possible for various reasons. Next one is lead time for changes. This one requires 2 data points, one of which is your deployment timestamp, so you've already got it. So the other one is your start timestamp, so therefore you get your time period by subtracting the start from the end. So for that change, you know what your takeaway is. And so therefore, yeah, like it says there, you take one away from the other. Again, what is your lead time for changes metric? You could just report how long the last pipeline took to run, right? But as you'll see when we get later on, sometimes infrastructure engineers trying to be smart and save money on Azure DevOps might, for example, reduce the pool size of the number of workers underneath your Azure DevOps pipelines and make a massive queue. So suddenly all of your builds start taking 4 hours. And there's a prize if you see which graph. You can see where they tweaked the pool size. So don't report the most recent, because maybe you'll look terrible. Or maybe the last build just flew through because of, for some lucky reason. You don't want to do the most recent. Again, you want to average the lead time over the last 31 days. Again, you can't average an average. If you calculated the average for a day, you can't then take the average of each day and then average that over the 31 days because you will end up with a false statistic. You need to go back to the raw data, which is the lead time for all of your builds, and then over the last 31 days and total them. Also, don't include change sets that aren't yet deployed. Because if a change set isn't yet deployed, like theoretically it's got infinite lead time. Right? It's not yet deployed. Who knows how long it's going to take? So this again it seems blindingly obvious to say, but if you're not really paying attention, you'll have loads of start timestamps, but you won't necessarily have a correlated end timestamp. You've got to make sure the two tie together, because if you've got a start with no end, you can't include it. So sometimes, again, Pete and I may have fallen into this, you'd be like, we should have a number that's a lot bigger. The number that we had was what was actually there, plus the stuff that was still in flight. And if your builds take a long time, you might have quite a lot of stuff in flight. So make sure that you don't fall into that trap, because we spent, again, maybe hours trying to figure out why two numbers weren't the same. That's why. So next one is change failure rate. So this one requires 2 data points. This is a proportion. So it's the number of resolved failures divided by the number of deploys. So we've got a number of deploys, already got that right. And this is resolved failures. Why is it resolved failures? Because we are also going to calculate the mean time to restore, or the median time to restore. I'll talk about that in a second. If we're going to kind of compare our mean median time to restore with our associated change failure rate, if we don't know what the time to restore is, we can't, we'll be comparing a certain number of change failures here with a different number of change failures there. And while it seems weird to ignore stuff that which is a known failure but hasn't yet been resolved, you will end up in weird discussions again because the two numbers won't total up. So what you do is you make it clear that it's resolved failures, and then you can do this. And then you can divide that by the number of deploys. Do not be confused if you end up with, and I may have seen this, a number which is greater than 100%, because it's a percentage, right? It's a proportion. I've seen a 500 or a 5x change failure rate. Turned out that there was a certain number of deployments, but there was a lot of failures coming from a third-party downstream API, which was kind of barfing all the time, and there was some really, really hair-trigger sensitive monitoring, and we were counting whenever the monitoring picked up a failure, if it was a failure in a downstream third-party service or if it was a failure in stuff that we'd written, those were counted. So for every deploy, there were 5 of those failures. So we had a 500% change failure rate, which looked bad, right? We had to explain it to management, but then when they figured it out, we tidied up our logging, no bad thing. Sorry, our alerting, no bad thing. And we could kind of focus in on the stuff that we were worried about. Next one here. So again, proportion of failures per deploy over the last 31 days. So as I said already, it's harder to accurately identify, it's flipping hard to accurately identify change failure. And this is where the first point where we start seeing the reason why the best way of doing this is for you as developers, because there will be reasons why. And as you set up stuff, your aim is to set up a raw, kind of just enough, probably quick and dirty set of version of these, right, with a spreadsheet and you going around with a clipboard, gathering this stuff. Then as you do it more, you'll start automating things. So therefore, you want to know about change failures, even if it's not a great measure. You want to know about them rather than not knowing about them, right? I want to know if I'm shipping crap, right? Pardon my French. So pick something and then constantly try and improve your definition, automate it, etc. And I think I've spelt tying. It always looks wrong, but Google tells me it's right. Don't bother tying failures to individual deploys. It is like, if you're at that level of maturity, which would be awesome if you got to that level of maturity, you probably don't need this talk. So you can forget me. It's like that Buddhist thing where you're like, someone teaches you and then you do it yourself and then you're so good you can forget the rules. So if you're that good, if you can associate individual failures with a specific change set, then you've risen above the level of needing the 4 key metrics. And then finally, time to restore service. 2 data points, when the ticket was opened and when it was closed. Again, ignore unresolved failures because you can't, the time is infinite. Until there is an end time, the time is infinite. And this one is interesting, right? The last 3 have been over the last 31 days. We were experimenting. We discovered that the last 31 days was really choppy because failures, like all of the other stuff, they don't come along in a predictable way. You want to get everything else into a nice cadence. The whole point of trying to, for failures is you're kind of trying to hopefully avoid them altogether. You want to kind of not have any failures. So when a failure comes, it's probably because of something unpredicted. So if you only look back over the last 31 days, you might have had a really rough time because something happened in AWS and then it discovered 7 or 8 other things you didn't know about in your infrastructure and there's a bunch of stuff. In 1 month, you look horrific. Another month might be just cool because it's all fine and everything's running and no product managers have asked for any schema changes to any databases or anything, right? It's just fine. Then you'll have a 0 month, flat line, everything's cool. So we extended it to the last 120 days because it flattens it out and it just, you can pick the one you want, but 120 was more meaningful. And you can start, hopefully you can see, what we wanted was, because this was for us, this wasn't for management, the whole point of all of these stats was so that we as the teams, developers, QAs, architects, tech leads, everything, we wanted to look at these numbers and go, right, okay, these numbers are where they are, they are where they are, right? What can we do to improve them? If it's change failures, what can we do to improve them? And like for change failures, just, you can make this better by spotting that it's broken faster and making it quicker to restore service. Everyone's a winner, right? Management love that, because that's awesome. I said I'd talk about median or mean. There's always a fight about this, especially by people who love statistics, many of whom have ended up as software developers. I Googled this a lot. The DORA people changed what they said at some point in the publishing of their things. It turns out that if you've collected all the raw data, calculating a median or a mean is super easy because you've got all the raw data and you just need to do a mean calculation or a median calculation. So what you want to do is pick the one which makes most sense to you to teach you what you don't know about your systems and how stable they are, so therefore you can take the actions to improve them, to make the business case, to spend more time fixing tech debt or something, right? So it doesn't matter. Well, maybe Dr. Fosgren is turning in her grave, even though she's not dead, the mention of this, but whole point is like improvement and learning. That's the spirit of DevOps, right? And I'm pretty confident she'll never see this talk. If she does see this talk, that's what you want to do. The whole point is like learning and the learning from ops and development and all this kind of stuff, right? Feedback, etc. That's what you want. There is a big, they do talk in the book about where they picked which one, but anyway. So that's this. So we've done capture and calculate. Now we're on to display and understand. So I can now show you the dashboards that Pete and I made, Pete and I love them because it's the only code we ever got to write. That's why there's a heart, because that's Pete and I loving them. But things to bear in mind, do the smallest possible dashboard. If your smallest possible dashboard is hand-collected statistics, wrangled by a human being for a single thing like deployment frequency, wrangled into a spreadsheet and then the numbers copied monthly into a wiki, do that, right? Then you've got one and you've got something and you can iterate. So don't do like the top of the pyramid, make it look beautiful and everything, but like don't have any of the rest of it. Do a thin slice, thin slice, thin slice. And actually, so also, like you might, again, I've counseled lots of people to do this as well. People spend ages getting exactly the right definition and totally tuning their New Relic, metrics and alerting and all this kind of stuff, all of which is good, but if you haven't got an actual metric to kind of discuss and look at as a collection of teams, then there's not as much benefit as there could be. So just get something there, caveat it, make it very clear, and this is why I say you need to be clear about the definitions. Share the definitions, make it clear to everyone what you are defining as a failure. So if people then disagree, and there was a great deal of debate on Slack as to the definitions of some of these things, but that's good, then people are engaging with these metrics, right? So, minimum viable dashboard version 0.1, manual everything. Minimum viable dashboard 1.0, automated data collection. Some people love writing bash. There's always an opportunity here to write bash. There's a lot of bash to get a lot of timestamp information out of Git, right? But number 2, this is it. 2.0, this is what Pete and I built. So, quick caveat, especially as one of them comes from us. There are third-party dashboards available. I have never used any of these, and I'm sure they're awesome. I did look at the source code for 4 keys to make sure that I hadn't completely, like, disagreeing with Google always feels like a bad idea unless you've checked. So how they calculate their metrics from the raw data aligns pretty closely with what I've told you I've done with the 4 metrics for data. These are good. The problem is they all plug into various things like Jenkins and Jira and Azure DevOps and everything. If you don't have all of the stuff that plugs into them, you will end up writing some stuff yourself. Right, number 1. Plus number 2, if you write it yourself, and caveat, we got to write code and we hadn't written code for a very long time, so we had a lot of fun, which was good. And we probably, like, half of it was on our own time as well. We didn't completely use, like, we're doing it a bit late sometimes. But if you've written it yourself, you can do all the coolness, and I'll show you the coolness. So, real life example. The number at the bottom right is the number. So this is an actual screenshot from Pete and I's deployment frequency report. So we would package this up and we would report this number and the 3 other numbers to management once a month. But it was a Power BI thing, and when we paid for the licenses, every developer could see this anytime they wanted, dynamically up to date. So this is all the data, all captured. So we could, that's our average number of deploys for the last 31 days, 26. But we graphed it. We counted the total for the last 31 days. We said how many we're doing today. We did 95th and 96th percentiles. We did rolling averages. We did loads of stuff. All of these extra things came from the fact that Pete and I, once a week, shared all of this data in a meeting that we had called the Architecture Advisory Forum, which is the talk I'm giving next, hopefully next, DevOps. We'd have this weekly meeting where we would discuss architectural changes, and half of it was driven from this. So we would look at this and say, okay, and then people would go, oh, what happened a week ago? I don't know, let's find out. That's where the percentiles came from and everything. Lead time for changes, same thing. This might be the graph where the person from infrastructure decided to reduce the pool size of the number of worker threads. Lead time 60 minutes. Again, last 30 minutes. You can see behind here, we shadow plotted the number of deploys. So you can see lead time for changes and the number of deploys behind them, because people kept asking the question, oh, is that big because there was a lot of deploys, or is it, why was it big? So we kept adding different things. Longest lead time, that's what happens if you save money on Azure for your pipelines. Change failure rate, this is the one I said, look, we had 1, because we weren't idiots, right? Occasionally we broke stuff. So there was 1 failure. But that could change a lot over a month, so therefore our change failure, we were doing lots of deploys, good thing, our change failure rate was lovely and low, brilliant. There you can see active failures. We weren't ignoring active failures, so we didn't have 1 failure, we had 5, but 4 of them were still going, so who knows when we closed them, that might have taken months. They were pretty good. But they might have, they were open, so we knew them, but based on our definitions, they weren't being reported to management. Management knew they were there, that we would tell them as they asked, but we were reporting things, and management knew that they were resolved ones. And then time to restore service. So here you can see the last 210 days, the mean time to restore, et cetera, et cetera. So you could see some big ones. I think most of the big ones were when Azure did something weird to us. Not always. And then small ones, et cetera, et cetera. So all of this stuff, trend lines, all these kind of things. Restored failures, 14, blah, blah, blah. And all of this was dynamic. So you'll see in a minute how we can do it. But this is the 4th thing, right? So we had this dashboard, and Pete and I continually improved this dashboard. And this dashboard aggregated all of the stats across all of the teams that we were working with. We were in the .NET world, so it was the .NET people. We, and it pains me to say this as a Java developer, we ignored the Java developer world, although they were very interested, and I think they've now adopted the same stuff, but they weren't in Azure DevOps, so we couldn't collect it, and Thoughtworks had no remit to annoy them, so we left them alone. But we would do the stuff, we collected all of the .NET team stuff, and we did it. And we showed them these statistics and these dashboards once a month, but they were available for them to look at any time they wanted. And that was the key thing, right? Because we wanted the teams to own them and improve them. They weren't targets. We had no targets. No one said, mean time for changes needs to be this number. But what we would like is it to go down. And if it goes up, it would be cool if we knew why. One Azure region kept falling over. That was our excuse. So yeah, so what you want is you want the discussion. You want people who understand what the metrics are and what direction you want them to go in. You want people to have conversations, right? And you want to tune and tweak, and that's what the angle brackets and the stuff and all these things are. You want people to use this as the basis for a conversation around about, should we invest time in decoupling some of these things, right? Some of our lead times, whenever we have to touch these two modules, one of which is owned by one team, which is owned by another team, the lead time for that is hard, just the testing and deployment of it. Or it always fails because the teams don't work together. So it helped us make arguments for architectural refactorings. It helped us make arguments for pair programming. It helped us make arguments for better test data management, because some of these things, doing the testing was a nightmare because the test data had to be set up in some weird and wonderful thing, because it was like a legacy system and stuff. If you've got these stats, again, you can go to management and go, we would like, it's technical debt, right? So it might not necessarily give you business value, but it will save you money, and that's what you want to do. And so what we always wanted to do is become elite. So the colors you saw on the boxes on the bottom right indicated whether we were elite, medium, or low. This constantly changes. I've given up updating this graph because as people are generally beginning to notice the 4 key metrics and are getting better, it gets harder to be elite, I think. It is correct that a change failure rate of 0 to 15% makes you elite, and everyone asks that all the time, and I can't remember why, but I can't remember why. Anyway, you can have a lot of failures. I think it comes from the run fast and break things culture, because if you break things a lot but you fix it really quickly, some people don't care. I do care. But if you're at Facebook, then you don't care. And so then, yeah, this is it. So this is what we used to report to management. But there's a key thing down at the bottom, and there's a bit missing because I forgot to screen grab it. So you can see there, it's dynamic. So you can change how many days you want to see, right? And you can change your start date and end date. So you could see what's changed over time. You could also, with a drop-down, select just your team's builds. So we collated all the builds, pulled them all together because it comes from those pipelines. There was a drop-down menu which came for free with what's it called, Power BI, and it would say this data comes from all of these builds. So then you could go in and select just one build, and it would repopulate all of this stuff for just one build, or all of your team's builds, and it would do that. We didn't tell management how to do that, so management didn't. The builds had weird and wonderful names as well. So they didn't care. So a team could come in and identify and interrogate stuff if they wanted to, but it wasn't ever reported to management. Management saw the aggregate number across all teams, so there was nothing in here that you could be used to say, this team is too slow, this team is too fast, because there's always a reason, right? And everyone's trying to get better all the time. And so if you want to improve things, that's where this graph comes in, right? And then the book has tons of stuff about it, and you can Google stuff, and if you really want, you can pay Thoughtworks, and we'll come in and help you do all of these things. But these things are standard, right? They're not, probably lots of you want the excuse to do loads of these things. Loosely coupled architecture, empowered teams, all of these things, right? Monitoring, better version control. All of these things. If you have these statistics and you want to get better at these, you just, send someone in management a copy of this book and go, read this book. We'd like to do these things to make this thing get better. And it works. So, conclusion, roll your own. I'm biased. I'm sure the ones that I've listed have got better and have more plugins for more things. I know you can write your own plugins for the Google one. I'm sure it's awesome. I'm sure the Thoughtworks one is awesome. It had X number of plugins last time I looked. It's probably got 10x number of plugins now. But the thing is on the right-hand side, right? You want to look at it, get feedback, learn, figure out what your priorities are, and evolve and keep changing. That's what you want to do. Because it puts power in your hands. So you can drive not just the fact that you've got a bunch of stuff to do and you know that debt's increasing. This gives you a thing to go, right, well, the only way to really move debt is if we pick these things up. How long does it take? So typically, it can depend, but defining and locating can take hours to days. Days is depending on how much debate. If there's someone who's got a degree in statistics, it could take quite a long time because there'll be a mean versus median debate which will go on Slack for months. But we just used to go, right, is it good enough to do version 0.1? Yes, right, cool. And then the debate would keep going, and then would be version 0.2 when we would change our definition. Capture and calculate days to weeks. Display and understand weeks to months. That's when you're doing it properly. And this one is the hard one. I've learned we were begging and borrowing developer time to automate lots of this collection. So some stuff took a long time, and meanwhile Kylie, which is why I call that Kylie was going off manually collating loads of this stuff. Lesson learned from me, I would have advocated more strongly for some of this, getting somebody in to do some bash or whatever. Write some crazy Jira queries. And then own and improve months to years. That does take a long time. So the extra special flashiness that Pete and I put in took longer, but we did it incrementally based on conversations. I'm not saying you should make dashboards that look like that. Make dashboards that look like you want. If 31 days is wrong and you want to do shorter or longer or whatever, because your cadence and your architecture and your culture and everything will be different. But they were kind of good for us. It worked kind of well. And that's what you want to do. So, health warning. That 4 key metrics tell you if you're building the thing right. It won't make a product which people care about. That's tied up. If the product isn't something people want, then it won't make a product that people want. It'll just be a well-built product nobody wants. So also do product metrics. Your product people will probably tell you this. I think that's it. Yes. If you want loads more gory details, that's the book. I only wrote a chapter. I didn't write the whole book. But it's on early release with better diagrams on the O'Reilly platform now. So, and if there's anything wrong in it, please give me feedback, because there's still time to change it before they publish the book. And I've got no time for questions, but I'm sticking around, so if anyone wants to ask me, I'm still here. Thanks very much.